Welcome everyone to another burst session. This session is focusing on computational fluency in grades 6 to 9 with a focus on instructional routines. And I'm turning it over to Shaheen Musani.
Hi there. So this session is building on some of the previous ones that we've looked at. Today, we'll start by looking at what is computational fluency. We'll look at some of the curricular competencies that students practice as they engage in computational fluency. We'll talk a little bit about what an instructional routine is and what kind of considerations we need to have in our minds before we start implementing. And then we'll go through a bunch of examples. So computational fluency is having efficient and accurate methods for computing. Really what we want to do is support students in practice so that they can interact with numbers and find solutions in efficient, effective, and fluid means. This means that we go through lots of different ways to determine solutions. We create a bunch of different experiences for them to practice at all points in our lesson structures. And we focus in and hone in on the topics of that are identified in the curriculum for computational fluency. When we're practicing computational fluency, we're growing procedural fluency, conceptual understanding, mathematical agency, flexibility, a strong sense of number. We're working with problems and hoping through all of that, students are becoming more confident, motivated learners around math. So these are specific curricular competencies connected to computational fluency. When engaged in learning, students should be invited to reason and to really hone in their estimation skills to be able to determine if a solution is reasonable or not. They can draw upon a variety of mental math strategies, use visualization as they determine solutions using pictures or drawings. They use a lot of different ways to communicate learning and particularly focus on using math vocabulary and language to explain their thinking. And at the end of a problem-solving task and or a computational fluency question, they should be able to talk about why their solution is reasonable and how they got there. And ideally, we want students to be able to connect mathematical concepts with each other. So as we go through the examples that we're offering today, think about what instructional strategies you often use in your practice and why you select them. Why are they effective at growing numerate learners and those who can draw upon more efficient and flexible ways to come up with solutions. What do you consider when you design your lesson sequences and units, and how are you currently addressing the diverse needs of your students in your math class? So the format for today, why instructional routines? We'll think about considerations as we're before we start engaging in them, and then we'll go through some examples. So why embed mathematical instructional routines? Well, an instructional routine in math are specific and repeatable designs for learning that support both the teacher and the students in the classroom, enabling all students to engage more fully in learning opportunities while building crucial mathematical thinking habits, right, as offered by the people on your screen. So as students engage in these practices over and over again, they get used to sort of the structures that are supporting these routines, but then also they're practicing a number of those curricular competencies that we outlined that are important to building computational fluency. And while doing so, they're engaging in concepts and competencies in an ongoing manner. We're providing access to all learners. We're encouraging student voice because they're sharing their ideas, and we're using their ideas to further develop the learning by extending it. the learning is rigorous, and that's how we can develop efficient and effective practices. But some things to consider before we start engaging in these routines is, what is our sort of learning goal? We have to have a clear learning intention prior to picking a particular routine, because the routine that we pick will determine, will be most suitable for specific outcomes. Also, we want to consider what our curriculum is, right? What those learning standards of focus are. We want to consider the structure and flow of the routine for both teachers and students. Remember, most of these are student-centered. So we want to think about how are we going to encourage that, in a very sort of structured way, at the same time as being able to stretch their thinking and to help them make those connections across content area or concepts in math. We want to create access points for varied learners, and we definitely want to encourage students to use math vocabulary and language that's pertinent to the concept that we're teaching. So we have to identify those prior to engaging in these routines. Sometimes that's in the form of an anchor chart. Now, a lot of our lessons in math are structured around this three-part process, where before learning, like at the very beginning of a lesson, we're trying to activate prior knowledge. We're identifying, like I said, some of that language and vocabulary that we want, to continue in our discussion. And then during is where we start to investigate ideas and or concepts in more detail. We practice some of the mathematical competencies that are of focus, and then we might engage in some problem solving, whether that be through a number problem or a task. And then after, we sort of bring or tie together the learning, and that might mean consolidating, it might mean reflecting, it might mean connecting, and we might mean practicing. So when we use an instructional routine, it can happen really at any point in this three-part lesson. Today, we're going to focus a lot on the before. That's kind of that 15 to 20 minutes before we get into students really diving into practice of that particular topic. And we'll look at some of the strategies that can happen during the learning too, for instruction. So let's talk about warm-up routines. Before we start naming some specific instructional routines that we can use, what we want to do is think about the vocabulary of focus. It's beneficial if we have an anchor chart or a word wall and identify which of the terms that you would like students to be able to use in their discourse, either with peers or with the large group in their sharing. This is an example on the screen that has to do with algebra, right? And it also has to do with some of the instructions that they might see embedded within the question, like simplify or find a solution. So we want to be able to break those down for children. Otherwise, they can't even access the question and begin to try to solve them. It's also very helpful to support students with sentence stems to try as they are engaging in that discussion. Some things that will help them to explain and justify their thinking. So these are some examples. I think because, I disagree with your response because, I would rather, because I use the blank strategy to find my solution, because my solution is reasonable, because. So if you have those up and students can see them, they're more likely to refer to them and engage in that as they're solving some of the problems that you're sharing. So when we're talking about some of those before learning or warm-up routines, we talked about how estimation is one of those instructional strategy, or is one of those curricular competencies that students practice as they're building computational fluency. And it's really important because it helps them to be able to rationalize whether their response or their solution is actually reasonable in the particular context that they're given. So I'd like to share a little bit around Estimation 180 and some other resources like the Steve Wyborny. We'll talk about number talks, and we'll look at would you rather. And there's a lot more. These are just a few, given the time constraints of our session, that might be effective in growing computational fluency. So when we're thinking about estimation, we're really thinking about computational estimation, which is finding the approximate answer to an arithmetic problem without actually computing the answer, right? So here we want students to develop their number sense, and then we want them to evaluate the reasonableness of their solutions. So some examples of that are at the top of this screen. Where students might be invited to estimate the product of a decimal question and then talk about what strategy they used and why. They might have to interact with integers, and we know when students are working with signs, they have to really think about, does their answer make sense, right? The next one is a real life problem, right? In context of shopping, where they are calculating the final price that would be needed to be paid for a item of clothing based on a discount. And we want students to be able to think about what makes sense when they're actually interacting with customer service, and are they getting the exact change they need? Did they actually calculate the discount properly before they paid? And the next is really to think about when they're working with fractions and its order of operations with fractions, does their answer make sense? So some of the strategies that we teach around estimation are listed on the left-hand side. We'll teach them about rounding, we'll teach them about benchmarks, we'll teach them about compatible numbers or process of front-end estimation. That's not actually the instructional routine, right? These strategies enable them to grow their reasoning skills, their connecting and applying skills, their justifying skills, and their explaining skills. But what are the routines that help them to be like flexible and efficient with estimation? And so something like Estimation 180 is actually what kids really enjoy doing, but they practice those particular competencies when they're doing it. So what is Estimation 180? It uses students have to use visual clues to estimate something about an identified object. So on the screen on the right-hand side, you'll see a picture of a pencil and a package of tissue. And there is a prompting question that says about how many tissues are in the package. And students have to reason and come up with a reasonable guess for what they think that the solution to that would be. And they have to provide evidence in their answer. So how does it work? You reveal the photograph. You ask students to notice. What do they notice? What do they wonder? What connections are they making? That you identify what the focus question is. You construct a plan to determine a solution, and then they have to justify their solution. So this particular site offers more than one option per day. There's a lot there, and there's some supporting documents that are available to, give to students to differentiate the learning. So this is invitational to all learners because they can all make guesses. Some are going to be more reasonable than others, but we want to encourage them to use math to come to a final answer, which is very similar to this one here, which is called Estimysteries by Steve Wyborny, again, online to find all these resources where your students are still estimating how many objects are in a particular container. Most of them are of that nature. But it's like a slow reveal. There's one clue given at a time. As you prompt them, they have to narrow their focus to come to a final decision about how many are actually in the jar, and then kind of rationalize how they got there. So these two are great routines, can be done within 10 to 15 minutes and support students with building estimation skills. Number talks are really important when we're developing computational fluency. But it's really important when we're engaging in a number talk that we choose or select questions with purpose. So we always have to have a learning intention in mind, and we want to think about how it is that we're going to provide access for all learners. There's different ways of implementing number talks, and there's a number of people who have written resources to support this. For the most part, students use mental math and computation strategies to determine a solution to an expression, an image, or a problem. They share their solutions, and then they explain and justify their reasoning. You offer a problem that's going to be invitational. Sometimes it's like where you want to start a new topic and see what they already know. Sometimes it's to review content that you explored the previous day, and sometimes it's to go deeper or to make connections. What is important to note is that teachers are really, like, the role of the teacher is really important in this process as students are engaging in this mathematical discourse. There's some structures and rules around how they participate, encouraging students to share their thinking initially with no words, just using hand signals, and then teacher recording all responses, whether they're correct or not, to show equality, and then reasoning with students, which one do you think is the most accurate and why? And then having students share various strategies for how they might have determined a solution. And while doing so, practicing the vocabulary at hand. So this is an example of an order of operations questions with integer. And in this case, when we ask them to calculate, we want to record all the answers. We want to observe what they're saying and doing to inform what feedback we give them, but it's also going to determine, be formative to us about what our next instructional steps will be. We name the strategies that they're using, the steps that they're taking. We encourage the use of the sentence stems that we've provided. We also provide opportunity at some point for students to share with a partner, because that just sort of lowers the expectation, gives an opportunity for processing and consolidating thinking to reach consensus. But then we also kind of extend thinking. What if we tried this? Or what if you did this in a different way? Could we come up with a solution, right? And this is another option. It is called a string of expressions. Some of you might have seen this previously. It is from the Number Talks, Fractions, Decimals, and Percentages book by Sherry Parrish. And you will see that these questions increase in difficulty from the first column to the third, and as we work from the top to the bottom. And you can decide how you're going to use these string of questions, right? We might start with just one set, ask them to determine the solution to one, and then after consolidating their thinking, start to say, okay, how can you use what we already know to help you solve the next problem? So it's structured in the way that we word the responses. It's given at the top of the slide there to encourage us to, practice some of the things that we have talked about in the previous solution. I also wanted to make mention that sometimes we practice more than one skill at a time when we're engaging in tasks. So we might ask students to use a number line to show how many different ways that you can show adding fractions to get the sum of one. Try using fractions with different denominators. And you can see that on the number line, they're both positive and negative numbers. And so students are working with rational numbers. You can obviously change this to meet your grade group expectations. Sometimes we might give students these individual whiteboards to show their solutions. Sometimes we might have iPads available to use a polypad for them to work independently or in pairs in determining these solutions. But because we're talking about relationships between numbers, we're also using number sense. So we don't have to do it in isolation, but we can talk about it with students to show what the difference is. And that goes to this example as well. When we're calculating the surface area of this composite figure, you will see that students are drawing upon their ability to multiply and sometimes add and or divide, decimals, as well as their ability to convert on their metric system. So what we want to do is encourage students to estimate before they begin the process so that they can check their solution at the end to see, are we close? How close were we? Is it reasonable? We also kind of want to hone in because this might be later in the year than when we actually were working with decimals previously. It's a nice opportunity to review and observe their work with operations with decimals. So would you rather is a really good instructional routine also to use at the beginning of a lesson, giving options for students. They have to pick a path and then justify it using math. There's so many different ways that you can go about doing it. This is one example that I have on the screen, but essentially what we want to do is have students kind of think independently first, use math to determine their solution, and then be able to talk about it and rationalize it with other people so that they can determine ultimately, is there a better place to work at in this example, or, what's the best solution? Then we'll move on to what are some actual lesson activity routines that you might have that you might sort of implement during that sort of longer phase of learning. So the first one we're going to talk about is 5 practices. It is a discussion routine. So how do you facilitate a longer type of discussion? This involves students actually engaging in some independent or small group work first before we share with a larger group. We want to also think about how we can introduce maybe debate into our classroom setting in math. And then we'll talk about non-routine tasks. So 5 practices is a lesson framework. There's 5 phases of instruction. There's anticipating, monitoring, selecting, sequencing, and connecting. So you might find you already naturally do a lot of these things as you're teaching. They're just, pedagogical terms that are connected to that process. But here's how it works. We identify a learning intention, always a goal that we have. The idea of this is to be able to engage students in some task where they're going to share their thinking with the larger group at some point. What we want to do is be very conscious of what is being shared so that we can be efficient. And so this requires us to select a question or problem for the whole class. And this might mean a little bit of differentiating based on student needs. We might have to select one or two. We have to think about what are some possible responses that students might share so that we can think about how we might respond to them. As we're as students are working in their independently or in groups, we are circulating to think about who we're going to call upon to share with the larger group. And this is because we've got in mind the particular processes that we think are going to be effective, the strategies that are effective that they're using, that we want them to share with the larger group. Then we kind of have to think about which order of is the sharing going to happen in, and then try to, at the end, make some connections between student responses and to key mathematical ideas. So here's an example. On the left-hand side, we were looking at what type of task to give students. So the top one just looks at, decimals. And the top one just is straight division using pencil and paper, inviting students to use the algorithm. But when we want to engage in deep discussion around process, we want to create some sort of rich questions. So we're going to ask them to solve a problem using at least two ways. We want them to explain their answer. In this case, it's going to have a remainder in the context of the problem, and they're going to be invited to justify their solution. So they're going to engage in this task. You'll circulate to think about, what are the processes that we want to share with the larger group that's going to have an impact on everyone's learning so that we can move it forward. And we want to think about what might be the barriers to some students. I apologize. There's some cleaning going on. Identify the supports that can be provided for those barriers so that they're in place and students have opportunity to grapple with these questions and, build some resiliency around challenging questions. And then after circulating, we have to kind of decide who's going to do the sharing. So debate is another way that we can invite people into a larger conversation. There's some structures for language around this. Students construct and share mathematical arguments to support their opinions and responses to problems using language. And then we invite them into that conversation by providing an open-ended question. And then students use arguments. So this is all sort of based on Chris Lesniak's work. That's a book on the side that he's written. He basically says that mathematical debate is social learning. And it's an instructional strategy. And it's a talking routine that provides opportunities for students to develop their mathematical thinking, for opportunity for them to craft arguments and to engage in mathematical discussions. So there's a couple of roles that students have. You propose a question, and then they have to construct an argument. And an argument is a claim with a reason. So they've got to come up with the answer and then be able to justify it, right? But they also have to listen to what others' arguments are so that they can respond with a rebuttal, right? And engage in some reflective process. It's helpful, again, to have some sentence frames around this as you're supporting them and having that discussion. So this is a kind of an example that you might give. What is the most common mistake you might see in this problem? So this is an algebraic equation. We're isolating a variable, and the variable is on the right-hand side. The larger variable is on the right-hand side. So we want students to really think about how are they going to determine this solution, but then also what might be some common mistakes that arise in this. They're using computational fluency because they're still working with integers in this process. So there is a structure for class debate on the screen you have here. I'll invite you to sort of look at that at a later time, just to think about how that routine can work in your class. And the last thing we'll talk about is a non-routine task. It's the what, which is, it's a highly engaging thinking task. It can be games or card tricks, or it can involve numeracy tasks. And so how do we facilitate it in our classrooms? Usually this is in small groups. We're using sometimes non-permanent workspaces, and we're scaffolding how to use the numeracy pathway to determine solutions to numeracy problems. So This is, these are some supporting documents we have on our portal on the left around what the numeracy processes are. This is a problem-solving pathway that the ministry has provided. They have very grade-specific ones, and we've made, taken the language from the ministry and tried to make them a little bit more accessible in the classroom for students and teachers. So what we're introducing to them when we're engaging in numeracy tasks and deep learning like this and connecting to various contexts is how we use this process to help us determine solutions. So there are on the portal some resources available for you for specific tasks that you can get, but also through the Thinking Classrooms book by Peter Liljedahl, and on his website, you'll find a few numeracy tasks that you can engage in with your class. You can also do some deeper inquiry type design questions. I showed this in our last session, where students might think about how math applies to real world contexts. There are a number of resources on the portal available for supporting computational fluency growth. If you go to our Numeracy Foundations framework and you click on computational fluency, you'll see a two-pager that provides some ideas for pedagogical design, some instructional routines, manipulatives, and tools that can be used, resources for assessment and things like that. So as we end, we want to think about how are the instructional routines that you're using impacting learning. We want to think about what structures and supports might be helpful to engage all learners in instructional routines, and how we might assess math and computational fluency during those routines. Thank you.